All right, chapter 3.1a, in case you missed today on Monday, here is the presentation we went over in class. The substitution concept is pretty basic. We substitute one value for its equivalent value and pretty much follow our instincts from there. So if you look at the problem here, again, this is 136, so what you're getting here is a higher level of substitution, but what you have here is that x plus y equals 11, and that equal sign is key in substitution, because it means that these two things on the left, the parts on the left and right have the same value. So what it means is that I can substitute every x plus y with 11, just like I could actually substitute every 11 with an x plus y without changing the value of it. So what we will do is we'll replace this x plus y with 11, and so therefore on a higher level, again, if x plus y has the same value as 11, then this x plus y can therefore be changed to 11, which means we know that the value of z is now 14. Alright, so again, substitution on a higher level is just maybe more creative, where you could use x plus y's and other things like that, but the substitution we're going to deal with is pretty simple. And again, you did see it last year in chapter 6. So if you go to the Google Classroom, you should also see that that those videos from chapter 6 are also up for those of you who need that extra practice. Again, here what we're looking at is you have y all by itself, and with substitution you're usually looking for a variable to be by itself. So you have y equals 3x minus 4, you have y equals negative 2x plus 11. You'll also notice on your notes that there are two different things going on. So go ahead and put I'll call it a box, but it's just a cheap word for box. It's a rectangle, but go ahead and put a box instead of these orange parts on your paper. And so box that bottom y, box that bottom negative 2x plus 11, and then since y is going to be replaced, we go ahead and put a box around where we're going to put it. And what would happen is this ends up taking the spot of that y because we substitute it, and you end up with negative 2x plus 11 equals 3x minus 4. Now that would be, as you'll see on your homework, substituting the bottom y into the top y, because there are questions where it says substitute the bottom y into the top y, and if you don't do it in this order, I think the computer just might mark you wrong, so just be careful on that. Or again, because there's a y on top and bottom, it doesn't matter which way you go. So on the second, we'll go ahead and do this also. Box the top y and the top 3x minus 4, and then we are going to put this in that place. So put this one here, and what happens here is that 3x minus 4 takes the place of this y, and you end up with pretty much the same thing. Again, 3x minus 4 on the left versus right is the same. Negative 2x plus 11 on the left versus right is still the same. So it doesn't matter which way you go. You can go either way on that. But what we now do is our algebra. Of course, we're going to move the negative 2x by adding it. 2 and 3 make 5. We're going to move this 4 by adding it. 15 equals 5x, and we're going to divide by 5 to get x equals 3. Doesn't matter which way you go, you still get 3 equals x on this problem. Now the thing is, what do we do to find y? Well, we still use substitution, because based off of this statement, these two things have the same value. And so what you do is you take any equation from the top and bring it down. Now I will admit, or I will tell you, that the best equations to use are the ones that have a y all by itself or an x all by itself, because it's easier to get your answer. But again, what this is telling me is that everywhere I see an x, I can put a 3, which means I can come down here and put a 3 in its place, of course using the algebra that we learned. 3 times 3 is 9, 9 minus 4 is 5, and that would be your answer. Now here's what you also need to know about substitution. You can take these two and plug them in. If I put a 3 right here, of course we know 3 times 3 is 9, 9 minus 4 is 5, which is your answer here. But you could also do the other equation and see that it works also, and you don't need to do both, but I'm just showing you. Again, here we can turn our x into a 3, so we do that. Negative 2 times 3 is negative 6. Negative 6 plus 11 is 5. Notice you get the same answer no matter what, but the proper answer that you're going to give is in an ordered pair, which means don't forget to always put your x value first and your y value second, no matter what order you learn it in. So that would give you your ordered pair of 3, 5. Alright. Another example again on your page. In this case, it doesn't matter if you're substituting for x or y, but in this case we see that an x is all by itself, so we are going to substitute for that x, so put a box around it. That x has the same value as 2y minus 11, so we put a box around that, which means we are now going to switch this for that x down here. Using parentheses, we use 3 parentheses 2y minus 11 and then continue on. Plus 5y equals 11. You then distribute the 3, getting 6y minus 33 plus 5y equals 11. You then put your like terms together, getting 11y minus 33. You then move your 33 by adding it, getting 44. You then divide by 11, getting the answer of y equals 4. The reason I'm moving so quickly again is because you've seen this already, and I think the algebra itself shouldn't be the issue. The main thing is how do we get from here down to our actual algebraic part, because we've been working on our algebra all year. But other than that, again, when you want the x value, copy one of these parts. You could put it into this, but the thing about that is there's extra work going here. But if you pick the one that has a variable all by itself, then you just take your y, which is 4, plug it in there. 2 times 4 is 8. 8 minus 11 is negative 3. And again, as an ordered pair, you would put your x first and your y second, which puts you right there. All right. And then the last example of this, at least, y equals negative x minus 9. Sometimes you get weird problems like this where you, instead of being a equation that we're used to seeing, you actually just have something to do. So again, y is the same value of negative x minus 9, so we're going to put that there. So box that on your paper, please. Then you turn your y into negative x minus 9. You then distribute your 3, making negative 3x minus 27. Again, the smaller x is obviously the negative x, so we're going to add 3 to both sides, making this 8, which means we must move our 5 over here, making it negative 32. Then we divide by 8, getting the answer of negative 4. Now, again, go back, copy one of the equations. Again, the best one is typically the one that has already a variable all by itself. We're going to put this negative 4 here, but you have to be careful because what a lot of people will do is they'll put negative 4, but this is a negative 4 and we're talking about a negative x, so make sure you copy this the right way. Negative parentheses negative 4 minus 9, which makes positive 4 minus 9, which is negative 5. Ordered pair, and that answer is negative 4, negative 5, but I want you to notice something here. What I did was I went to one of my software programs and I graphed this and this on that software program. So this is actually the graph of both equations, and what you should notice is if our solution is negative 4, negative 5, what does that actually mean? And what that means is, if you follow this little dot that's about to come in here, this is negative 4, negative 5, and what's special about that is that this is where these two lines actually intersect. So if you are asked without any kind of equation what the solution of the system was that was graphed, you're looking for the spot where the two equations cross. That is the solution. Alright, so again, negative 4, negative 5, that is your solution there. I'll even show you the one from example number 2, I believe it is, where I graphed those two. Actually, I think it's, yeah, first example, I'm sorry, number 1. But I graphed the first example where we got the answer. I don't remember what the answer was because I don't have it in front of me, but I do believe that your answer was over 3 up 5, 3, 5. So again, if you notice, 3, 5 is your solution here. So it is consistent with what we would think in terms of that. And just to make sure we understand something along the way, what's the solution to the system graphed above? Looks to me as if both of these lines are going the same exact direction. And what that means to me is that they are parallel. And of course, parallel means the lines will never cross. And if the lines will never cross, that means that there will be nowhere that these two numbers are going to give us an ordered pair, which means that in this situation, when the two lines are parallel with each other, the answer is no solution. Alright, so again, just kind of check that out. Make a note on that in terms of your number 4 to make sure you understand why it's no solution. It's because the lines don't cross. But other than that, like I said, go ahead and go into your Math Excel, get some practice, and good luck.